speaking. Can you please go on mute, please? I promise you that at the end of this talk, you will learn some of the fundamental principles about systems thinking. And another equation that I am bringing in this talk is bringing systems thinking philosophy in an agile environment. Most of us are working in an agile environment. So how can we really apply some of these ideas? Systems thinking as a concept itself takes years and years and possibly decades of practice and learning. I've been learning since 2003. My first book, I came across Craig Lorman, who was one of the co-inventors of LESS in 2003. And he said that, hey, Venky, systems thinking is something that you need to learn. And here is the book. This book is Peter Senge's Fifth Discipline. I highly recommend this book. But when I immediately ordered this book from Amazon and started reading this book, I didn't understand anything. So I read it once, didn't understand, read it twice. But over a period of time, as I gained more experience and I was able to connect a lot of dots, I was able to do that. That's one book. And of course, in the course of this talk, I will recommend a couple of more books as well. Without much ado, let me jump onto this topic. Thank you, Will, and thank you, Agile Perth, for giving me this opportunity to share some of my knowledge, both in the context of systems thinking and agility here. Quick intro about me. I started as a C++ programmer because I had a computer science engineering degree. So for me, it was easy for me to get into a programming. But over a period of time, I moved away from programming and I moved towards architecture and technology architecture, solution architecture, played different roles, BA, SM, PO over a period of time. I was also into pre-sales for some time. I also am a trainer. Some of you know that I do a lot of LESS training. Now I'm spending a lot of my time in the last several years in coaching teams and trying to bring various concepts, whether it is a complexity design, systems thinking, and agility, lean thinking, and into software development. As I said, I'm a LESS trainer. If you're interested about training, we can chat later, but I provide three types of training, one for executives, one is the LESS basics and a LESS practitioner. And there is also an online version of LESS. You're free to reach out to me whenever you have a chance. Before we jump into any of the talks, let's do a quick poll here. So Will has shared the Mentimeter code. Here is a quick poll. As you can see here on my screen, the question is, what is stopping you from applying systems thinking at work? I have given 4 options. One is not enough knowledge of systems thinking. That's why you are not able to apply. Haven't seen its applicability before. Leaders don't understand. It is too abstract, theoretical. So please use that menti.com and the code that Will has shared. Cast your vote. Woohoo! People are still voting, but looks like not enough knowledge about systems thinking seems to be the winner here. Leaders don't understand is the second one. Haven't seen its applicability before, and it's too abstract and theoretical is a fourth one. All right. Thank you so much for the votes. Still people are voting, but looks like the first one is the winner, not enough knowledge. Before we jump in to the topic, let me ask you a quick question. What is a system? We keep saying the political system is not working well, or it's not good. The educational system is not good. What is system? What is a system? What is your understanding of a system? There's no right or wrong. Don't be shy. There's no wrong answer here. Just share your thought.
Simply, like, most simple way is probably like actors interacting with each other.
Interacting with each other.
Yeah, actors, or whatever the item may be.
Excellent.
Is it like cause and effect system?
Sorry?
Oh, what is system? Oh, I lost, sorry.
Yeah, that came through. Yeah, I think there was is it a cause and effect as part of it? Yeah.
Cause and effect, okay.
Yeah. I was going to say like a group of interconnected things.
Yeah.
Right, I think wonderful. And also see that Michael has responded saying that it's a black box with inputs and outputs. Pete has mentioned things working together. Andrew said it's a collection of parts that together do a thing. And Will has been, answer has been the group of interconnected things. And Shashi says it's all beliefs. Wonderful, great answer. Let us look at my favorite author, Donella Meadows. Again, as I mentioned, as I promised before, that I would want to share a couple of books. Definitely, I recommend Fifth Discipline by Senge. And another book that I recommend is Donella Meadows. I'm writing it on the chat window. Thinking in Systems, the primer. The Meadows books are easy to read compared to Senge's. Of course, it's my experience, or you might be in a different space altogether there. From Meadows, what I say is that a system is a set of related components that work together in a particular environment to perform whatever functions are required to achieve the objective. There are very, very important words that you need to remember when you're articulating a system. You cannot call anything and everything as a system there. Of course, there are a few boundaries. Looking at this particular definition, first of all, as all of you mentioned, it was wonderful that it is a set of interrelated components. That means that if you want to call as the system needs to have some components, first of all. Having components is not good enough. The components needs to be related to each other. There should be some kind of a relationship between the components. What's next? Again, that's not good enough. They also need to be working together in an environment. So we need components. The components needs to be related to each other. They need to be interacting with each other. They need to have an environment. And the most critical aspect is all these components are working towards a common objective. Let me give you an example of a car as a system. So let's start with, looking at the same definition. Let us start from the bottom of the sentence or the definition. Let us look at the objective. What is the objective of the car?
Getting from A to B.
Yep, it helps transporting people or anything, people from one place to another, right? That's fantastic. Transportation from place A to place B is its objective. In order to meet those objectives, or in order to meet that objective for a car as a system, what kind of components do you need?
Need an engine, fuel, body, seats,
Excellent.
wheels.
There you go. All those things, that's fine. Now, so we know that we know the objective, we know the components of the system. And of course, they all interact, they're all connected to each other in some way, isn't it? Right? Wonderful. That's where the system comes into picture. They're all designed and are made to work in a specific way so that car as a system can achieve its objectives. Let me ask you this question. I take the same car and I will disassemble the different parts and I will throw it in a pile. Is that a system? No. Why is it? Why is it? Why is it? Yeah, it's a junk. Why is it not a system? It has all the car parts. It is exactly the same thing. Because now it cannot meet its objectives that we want as a car. Second thing is, it has all the components, but none of them are interacting with each other. Even if you take the same set of components and if you put in a different way, configure in a different way, it might move, but it may not do the same objective as a car or whatever the objectives that you have set. Similarly, in the context of organization, let me ask you a question. What is the objective of your organization that you are currently working? If you consider your organization as a system, it could be anything. If you don't know, you can just you can just say something. You can cook up something. But if you know, that's really good. What is the objective of your organization as a system?
Cynically speaking, is to be financially stable and to grow.
Yeah, financially stable. Possibly that's one of the objectives. Absolutely.
And growth, I said. Yeah, growth as well.
Growth, wonderful, excellent. Any other objectives? Anyone
Get more customers to sign up to my app.
Well, get more customers to sign up my app. That's wonderful. That's the objective of one of your system. That's fine. Now the question is, in order to achieve that objective as a system, what components do you need? What do you need to achieve its objectives?
People, processes, and technology.
You need people.
Technology.
You need technology. What else?
And processes.
Processes. Customers. Right? All those things. You need all those things. But again, if you just get all of them and then pile them up, it becomes just like the pile of rubbish that we talked about earlier. Getting these components and knowing these components is not good enough, but making these components work in a specific way is what makes the system critical. If you have these components or components not, if you don't have the components in the right place at the right places and configured to interact in the right way, or if you have them, but they're not doing what they are supposed to be doing, your system might be having components, your system is interacting, but it may not be achieving the same objective you want. That is one of the major problems in the organization that we are currently working. The organization is so complex as a system that we don't know what kind of components we need in the system and how do we make them to work with each other. Most of the time, what we do is we think that we go and hire people. We have these different departments. And then we say that, okay, you guys talk to each other and here is a problem you need to solve. You just go and figure it out. They will figure it out and they will do something, but they may not be achieving its objectives. Most of the time, why most of the project deliveries fail and why most of the organizations struggle is because of exactly the same reason. You might have fantastic, brilliant programmers, HR people, finance people, but still organization is struggling. It is not the components of the system that is having a problem. It is the components are not configured to interact well. Are you with me so far? Now let's look at, we looked at system. Now we understood what system is. Let me ask you a question. What is systems thinking?
How do we connect all the puzzles together?
How do we connect the puzzles together? Yeah. Belief and buy-in, outside in. Some answers I'm reading from the chat window. What is systems thinking?
Is it, Venky, an appreciation or an attempt to understand like the wider system at work?
Yep, absolutely. In fact, this is exactly one of the challenges in the current scenario. When you Google around what is systems thinking, you get literally thousands of answers. However, something that I found interesting was that you look at any of the definitions. This page of what you're saying has 4 definitions of systems thinking. Take a minute and read it. And I've highlighted some of the things that I see as a common pattern in any of the definition of a systems thinking. So you look at any definition of a systems thinking, you will always see the words like structures, patterns, cycles, relationships, the interaction, boundaries, perspective. These are the common words that you see. Fundamentally, if you want to call yourself as a systems thinker, some of the things that where you need to practice is to identify what are the constituents of a system. You should be in a position to identify the objectives of a system. You should be in a position to identify the relationships between the components that is helping us to achieve the objectives. Remember, going back to the same examples, having the brilliant programmers, project managers is not going to solve your problem. It is not the components of the system that is making the system work. It is the interaction of the components in the system is what is making the system work. If the interaction is not fixed, you will not achieve the objectives that you want to achieve. So fundamentally, if you want to become a systems thinker, you need to build that ability to see not only the components, but also the relationship between the components and what are these component interaction resulting in the behaviors of a system. And how can you configure the relationship of system so that you can get the objectives that you want to achieve. You need to step back a little bit. And one of the most important, very important thing that you need to know in this context is the word boundary. From a systems thinking perspective, the entire universe is a system. We don't know the objectives, but we just know that it's a system because we all have components, we are all actors, and we are all interacting with each other. We are doing something, but our system is so complex, we don't know what it is trying to achieve. However, we can't solve this problem. Our most of the focus is day-to-day activities like solving a project management problem, delivering a software, or doing a product development, or hiring someone, or setting objectives in the company. How do I make profit? How do I make revenue? How do I get new customers? Most of our focus is concerned around organization as a system. So what systems thinkers say is that since the entire universe is a system, we can't consider the entire system while you are solving a problem. So you draw a boundary to solve a particular problem. And in that context of the boundary, you call it a system. So for example, we call organization as a system when we are solving the problems in the organization. You can have your own system as in your own project as a system if you are solving a problem specific to your own project or a product development. But you also need to remember as a systems thinker that your boundaries, what you are drawing, is a virtual boundary, because since the whole system is very, very complex, we draw a boundary and we also make a lot of assumptions that within this boundary, we try to solve whatever we can, which is under our control. Are you with me so far? So another quote from Meadows is, there are no separate systems. The world is a continuum. Where to draw a boundary around a system depends on the purpose of the discussion that we have. Let's go back to system optimizing goal. As I mentioned before, every system has a goal, right? We discussed about the car as an example, and we discussed about a few examples from your organization. And also we saw that every system, in order to meet its objective, you need to have the right set of components in the right places. If you are designing a car which can travel 60 kilometers per hour, in a usual city side district, then you need to get the parts that helps you to achieve that objective, which can go from 0 to 60 kilometers only, or maybe 100 kilometers. Just because Airbus 380 has a new engine, you can't fit that engine into your car. It won't work. Just because Benz is manufacturing a wonderful set of tires, you can't just bring Benz tires and try to fit it into your tire because your car, just because you want the car to have wonderful tires. Because in order to meet the objectives, you need to be extremely, extremely careful in selecting the right set of frameworks, components, and methods. Now I'm kind of slowly coming back into your organization. If you're looking at product development or a project as a system that you are trying to solve, you need to ensure that the right set of methods, tools, components that you select in your project should be aligned with the objectives that you want to achieve. That's what we call it as a system optimizing goal. Every system has an optimizing goal. That's where, when it comes to frameworks and methodologies, most of the time what we see in the industry is people go based on the popularity. People say that, okay, I want to choose a scaling framework. What do I do? Okay, everyone is talking about a particular framework. Let's just go and get it just because someone said so. That is one of the most, sorry to use a strong word, ignorant way for selection of a framework. Because if you are considering a product as a system, every tool that you select is designed to achieve a certain optimizing goal. If you are designing a car, each and every nuts and the bolts, including the oil and including the design of the motors that runs there, the belts that is used, everything is designed specifically to make that car work. The same concept applies to software development in the Agile context, in the Agile industry as well, that every framework and methodology is designed to achieve certain objectives. Whether you are cognizant of it or not, it doesn't matter. If you might just go and select a framework and start implementing your project and you will get some answer, but you might struggle also. But how do you really know that the optimizing goal of the framework and the methodology what you're choosing is aligned with the framework and is aligned with achieving the project's system optimizing goals? So if you're a consultant, agile coach, never ever go to a company and just tell them that here is a framework that you need to use. The first question, if you want to really, really take away one thing from this talk, is that first thing you need to ask the stakeholders is, what is your optimizing goal? Trust me, most of the time they'll give you some answer, but many a times it may not be true at all. But as a coach, first thing is to understand what is your project's optimizing goal. Then go back and do a study about the different frameworks and the optimizing goal of each of the frameworks. Guess what? It's not a rocket science. Luckily, the two frameworks that clearly articulates the optimizing goal are Scrum and Less. I'm not making it up. This is actually from the Scrum guide. If you just Google around, get the latest Scrum guide. I'm just reading the Scrum theory here. Scrum, I'm looking at a second paragraph here in the Scrum theory. Scrum employs an iterative incremental approach to optimize predictability and to control risk. If the optimizing goal of the work you are doing is to achieve certain predictability and to control risk, Scrum comes handy, right? Again, another critical aspect that you need to remember is when Scrum itself, as a system, is designed in a certain way. And if you want to achieve the objectives of Scrum, you need to do what Scrum says. If you don't do what Scrum says, you won't get what Scrum wants you to get, right? That's where Scrum clearly articulates, looking at the second paragraph. The Scrum guide contains the definition of Scrum. Each element of the framework serves a specific purpose that is essential to the overall value and results realized with Scrum. Changing the core design or ideas of Scrum, leaving out the elements, or not following the rules of Scrum covers up problems and limits the benefits of Scrum, potentially even rendering it useless. Are you with me so far? Scrum is designed as a framework. So Scrum itself is a system by itself. The reason why it has your daily Scrums, why it wants your daily Scrum to happen in a certain way, why it wants your retrospectives and the sprint reviews to happen in a specific way, why they have recommended the 3 rules to work in a specific way, is all towards achieving the optimizing goal of the predictability and to control risk. You're free to change. Of course, Scrum is not going to stop you from doing it. However, when you change the parts of the system, when you change the interactions of the way in which the recommended framework or a methodology works, you are not going to get the outcome it wants. It's just like changing all the configuration of the car. There is a car design. It says that this is how you need to design the car. But we say that, oh, you know what? We don't want that. Our organization already has certain things, so we will change it. Instead of the driver's seat in the front, we will put the driver's seat in the back. We want the passenger to be sitting in the front. We want the boot to be on the top. You can design whatever way you want. And then finally, we say that car is not going as per the design. So there is a problem with the design. It's not the problem with the what the manufacturer has given. Manufacturer has clearly said that if you want to achieve the optimizing goals, this is the way you need to design. You are free to change. No one stops you, but you may not get the same objectives that you want. Are you with me so far? I'm just taking an example. Similarly, another popular framework which gives you the optimizing goal, which clearly articulates, is Less. There are so many frameworks. You have SAFe, you have DAD, you have Spotify. However, none of this framework clearly articulates what is the optimizing goal. There's nothing wrong with it, but it is our duty as Agile coach and consultants. There is no right or wrong here. I'm not saying one framework is better or one framework is wrong. There is nothing right or wrong in the world. What I am recommending here is that focus on the optimizing goal and choose the framework to achieve your optimizing goals. Are you with me? That's all it is. You need to marry the optimizing goal of your organizational context and your project delivery to the optimizing goal of the framework. That's all I'm trying to say here. So if I am recommending Scrum or Less, I would look at the optimizing goal of the company and then recommend it. So Less's optimizing goal include delivering highest value to the customer all the time and building an agile organization or adaptability, building an adaptable organization. So every framework, every practice, every role that is designed in Less is to achieve and help the organization to achieve agility or adaptability and to deliver highest value to the customer. You might have various other frameworks. What I highly invite you is to go back and understand what is the optimizing goal of the framework. If you don't understand, you need to study a little bit. There are ways to understand how to do the optimizing goal. I can take you through that, maybe in some other session. And of course, your project optimizing goals. Then you need to marry them together. It's extremely critical as a systems thinker, and especially if you're working as an agile coach or a consultant in an organization, and if you're recommending something. Peter, you're on mute, Pete.
Sorry about that. Yeah, what you're saying makes a lot of sense to me, but a question I have is, when we're selecting a framework, choosing a system designed to meet and optimizing a goal that works for you makes sense, on the assumption that its design actually does fulfill that goal. And I guess this is where it gets a bit more subjective, how evidence-based it is. I mean, I don't think we choose frameworks for evidence in reality. As you say, it's more on popularity contest. But I just think that's obviously, and you made this point that if a car is designed a certain way or intended to be designed a certain way, it doesn't mean it's always a great car. I mean, some designs don't work as well as other designs. So it's not just about choosing one with the right objective. It's also choosing one where the design is good for that objective.
Absolutely. Absolutely. Spot on. Spot on. Spot on. We need to look at a lot of contexts. We need to look at the context where the car is going to operate. And then, who are the users? What kind of need they have? How do they want to use the car? And then you need to choose the right set of components. And then not only choosing the components, and you need to marry them together so that they can work in a synchronous way to achieve the objectives of the system. And that's where the complex comes into picture, and systems thinking hat plays a critical role. Again, I'm just giving a hint that in the coming weeks we'll be doing less course, and we cover a deep dive into systems thinking and bringing the applicability of these ideas in the course as well. So key takeaways: observe the actions and understand what is the system optimizing goal. If you're an agile coach or a consultant, then based on the observation, then you suggest the tools, methods, and frameworks, and avoid recommending tools and frameworks and methods based on the popularity. Let me move to the next important topic. One of my favorite authors, Deming. Of course, Out of Crisis is another book. So this is another book that I highly recommend, Out of Crisis by Deming. So from Deming's perspective, when we optimize subcomponents of the system, we don't optimize the overall system. Or if you want to rephrase it, local optimization is always suboptimal in the context of global optimization. Let me pause here quickly and ask you, what did you understand when I say local optimization is suboptimal in the context of global optimization? Or as per Deming, when we optimize the subcomponents of the system, we don't optimize the overall system. What did you understand?
Well, Venky, we talked about earlier that it's the relationship between the components in a system. If you're optimizing and focused just on optimizing one part of it and not focusing on the interrelation between the parts, you're not going to get a good system communicating and talking together. Well
done, Matt. That's a great answer. Any other answers?
Along the same lines, if we're focusing just on the part that we are looking at it, that we care about, we're not considering the impact elsewhere.
Sorry, can you repeat that again? Sorry.
But sorry, I'm probably saying the same thing that we'll. So different word. Yeah, if we're only focusing on the local part, we can't understand what the impacts would be on the other components.
Fantastic. Absolutely. If you are trying to focus only on the parts of the system, and if you want to make the parts of the system efficient, you might be inadvertently bringing down the optimizing goal of the overall system.
And
So
the
let's go.
And the disappointing thing is, Venky, we see it so often because people in their own little part of the system want to prove that they're best. They've got the best system, the lowest waste system, but low waste is not necessarily best for the whole system because it's almost selfish, right?
Spot on, spot on. Many times people go on efficiency rampage. Oh, we want to do efficient. We want to remove all the wastes, or we want to do that. However, the problem is not with the mindset of making a system efficient or making it more productive or whatever the goal is. However, people lose the focus that when they are trying to make their particular department efficient or more productive, they might be bringing down the efficiency and productivity of the overall system. Because as we said, the system is not alone. It's not a siloed thing. They're all connected to each other. You know, you are designing the the tires, and you want to make one of the tires more efficient because their boss told this particular tire manufacturer that if you make your tire more efficient, you get bonus. So one of the tire manufacturers just went ahead and made one of the tires so efficient because they came up with a new design, more aerodynamic design, maybe a square shaped, but they forgot that the car cannot run on one tire. Car needs all the 4 tires, and the rest of the 3 tires are manufactured by a different manufacturer who had their own objectives. If each of the car manufacturer or the car tire manufacturer of the 4 wheels, if each one is going and designing and trying to make their tire faster, they might make the tire faster, but the car may not move at all. So in a complex organization like a company organization, software development, or an agile project management work that we do, we have so many parts, and many a times we have these parts siloed. No one of the components don't talk to another component, and there is one department they don't talk to another department. And in that whole process, especially that you bring the KPIs and all sorts of metrics and measurements to improve the efficiency of that one particular part of the system. However, the overall system might be hurting quite a bit. So you need to remember this. If you're a systems thinker, another key takeaway from today's talk is that please be conscious of the local optimization problem. Are you with me so far? So Bruce is asking a question, what is the alternative to local optimization? So the global optimization is the focus. You always need to focus on what is the optimizing goal of the overall system rather than the local optimization only. Local optimization, as long as you are locally optimizing, but it is also helping the global optimization, you are on the right track. Just focusing on the local optimization without the focus on the global optimization is where most of the problem arises. I'll give you some examples in the coming slides. This is one of the most common examples that we see in the system, the component teams and the feature teams. Right? There's nothing right or wrong about this component teams or the feature teams, but component teams are optimized for something else compared to feature teams optimized for something else. I know it's a very simple concept. Many times people use the words, oh, we need to have a cross-functional feature team. Scrum says cross-functional feature team. Less says cross-functional feature team. But why? Why not component teams? Because the Scrum and Less are designed for a certain optimizing goal to help the organization to achieve the agility and value. In that context of that, the cross-functional feature team adds value. Component teams, there's nothing wrong with it. It still works. However, component teams are optimized for something else. So if your organizational optimizing goal is something else, go with the component teams. So I've given a few examples there. Component teams, an example is they're optimized for delivering more code. You have a Java team, you have a separate QA department, separate DA department. Each one is optimized only to improve their own perspective. See, at the end of the day, customer don't care how good is your BA team, how good is your testing team. The customer says that am I getting the value that I want to get from this feature? Your BA team might be highly efficient. They have a separate BA team, is a component team. You have a separate testing team. They are highly efficient, one of the best testing teams in the world. But if each one is doing whatever they want and they have their own product owners, if they have their own product backlogs, and that's how most of the organizations work, we are not achieving what the customer wants, because no one is looking at what customer wants. Everyone is looking at, how do I deliver my backlog for testing? How do I deliver my backlog for BA team? That's where the component team comes into picture. And that's where it's harmful, when your focus is on delivering value and the agility to the customer. That's the reason why Scrum and less advocates go with cross-functional feature teams. Are you with me so far on this? How much time do we have, Will?
We have about 10 minutes left as advertised, Venky.
10 minutes left. Should I continue or should I stop? What do we do? Continue?
Yeah, so it's up to you, Venky. So I think, maybe continue, and then we can stop with some questions.
Yep, sounds good. So classic example, again, going from component team, is that we have a GUI team, middleware team, and database team. If you have this component team structure, each one is designed, and if you have their own set of backlogs, they are designed to do their own backlog items. No one is looking at the end-to-end team. And what happens if you try to make one of the team efficient? GUI team went ahead and they said that, oh, we have a good coach there. And the coach reduced the cycle time from 10 seconds to 4 seconds in delivering certain set of features. I'm just taking an example. What happened? Yes, they did very well. However, the backlog of items, all the UI items, whatever they have delivered, started accumulating in front of the middleware team, because middleware team, they didn't do the efficiency work, or they don't have the necessary set of tools to reduce their cycle time. So we made one of the teams efficient, which is locally optimized. But overall, the queue started building in front of each of the teams, because the rest of the teams are not as efficient as this particular team. Another classic example mistakes people do is improving cycle time. Again, there's nothing wrong with it. However, most of the time what happens is people go, and especially working in a siloed component mode, they keep working towards, oh, I want to improve my cycle time. I want to improve my cycle time. However, no one focuses asking, is the lead time improving while I'm improving the cycle time? Just the cycle time improvement, many times you might actually, if you want to go back to your organization study, if you hear wherever someone says that, oh, I've improved my cycle time, and if you go back and measure the lead time before and after, possibly the lead time might have become worse, because they might have gone ahead and done the local optimization. Again, I'm not saying that cycle time improvement is wrong, but I'm saying that cycle time improvement doing locally without looking at the impact of improving the global optimization is where things go wrong. Are you with me so far on that? Quickly, I'll go through this one. Again, we go deeper into the tools in like causal loop modeling and other things in the less course. But there are several tools as well, apart from the thinking philosophies of what I discussed so far, and several principles in systems thinking. Tools like System Iceberg, Compass, behavior over time, stock and flow, ladder of inference, causal loop diagrams. So many tools are there. I'll just quickly look at the causal loop diagram here. That's very simple and intuitive and easy to see. So again, we use the CLDs, or some people call it the systems modeling, when you want to see the cause and effect and how things work together. In this example, what it's trying to show is that the population leads to births. That's where you see a plus sign there. When the population increases, births increases, and when the births increases, population increases. Same time, the population, when increases, also the number of deaths increases. And when the deaths increase, population decrease. That's where there is a minus here. One of them is called a reinforcing loop, and another one is called a balancing loop. I'm not going deeper into this one. This is not a course about causal loop modeling. However, I just want to introduce you to ideas that when you're dealing with complex system, and if you want to see how the parts interconnected and how they operate and how each one impacts the other, this tool can be handy. Here's another example. What's happening here?
Is it they're hiring more developers that are creating more defects, so they're hiring more developers again?
Yeah, pretty close, Will. There, you're spot on. So what's happening here is that the company wants to improve the velocity. They have a lot of money. They said that, hey, you know what? We want to get this features delivered faster and faster. Go and get more and more people. So the intent was to improve, create more and more feature velocity. So what's happening here is that they hired more and more developers, and these developers created more and more features. So your feature velocity increased. However, the developers who were hired in rush, and they didn't have proper skills, so that they created more and more defects. So they started spending fixing more defects. And what happened? The velocity, the feature velocity started going down. So the whole intent of hiring the developers was to increase the velocity. So initial days when you hire those developers, immediately you will see a jump in the velocity, and everyone will say, oh, see, we have made the right choice here. We hired 4 developers and our velocity gone up from 40 to 60 story points, or whatever it is we can say. However, over a period of time, if you actually observe, what happens is, they started creating more and more defects, because testing comes in the end. So people start testing. As soon as the testing team or everyone starts testing, they identify more and more defects, and it comes back to the backlog. And since they are severity defects, it gets prioritized more than the velocity on the feature development, and people start spending more time on fixing the defect rather than delivering the actual features. And this all things happens over a period of time. That's the reason why many a times in a system, the cause and effect, you don't see they're playing out immediately. Many a times it takes a long time. Sometimes the decision what you made today would have an impact. You will see the impact of that maybe at the end of 2 months, 3 months, 4 months. People don't know, because system is so complex, they can't correlate. Nicola asked for what is QF. QF means quick fix. So when we have a quick fix, then any decision that you made, a quick fix decision, rather than thinking throughout the system, is where the systems plays out. And of course, there are notations here. There are different notations we are using here. There are different plus and minuses where people use to show that one is impacting the other in the same direction. Another one is impacting. In another model, people use C and O for the same things, which shows that it has a direct correlation and opposite effect. In this particular case, when you have more cache supply, you will end up having more developers, and number of defects will have an opposite effect on the feature velocity. That's where the O comes into picture. There are different notations while doing causal loop modeling here. Here is another complicated one, but we don't have to really worry too much. Many a times people say that in a system we blame someone else. As we said before, sometimes we say that our leaders don't understand systems thinking, or someone doesn't know what it is. That's the reason why we are not able to do systems thinking. The poll what you're seeing on the right side is from one of the meetups, where most of them said actually that the reason why they are not doing systems thinking is because their leaders don't understand. And fundamentally or paradoxically, systems thinking says that the cure lies with the relationships with the very people we typically blame for the problems we are trying to solve. In a complex adaptive system, there is no separate other. Each one of us, we are part of the system. We are contributing towards whatever is happening around us in some way or the other. It is not the other person. Everything and everyone is connected, and together we co-create the whole system. Sometimes we have difficulty with this. We reflex to blame, we deflect, and we deny. It is hard to take full responsibility for something that seems to be outside of our control without trying to control everything. So if you are a systems thinker, or if you want to become a systems thinker, the first rule of thumb is you need to become more humble. Because we need to remember that I am the cause of the system. I'm also causing whatever is happening around me. It is not the other person. So the question as a systems thinker I need to ask is how I'm contributing to whatever is happening around me. Right. Last but not least, Will and I, we are hosting a certified less practitioner course in Perth, for the Perth, specifically for Perth people on 15 September, a couple of weeks. Feel free to reach out to me or Will if you want to know more information. Here is my email address and dates and other things. Will can share it in a group, or one of us we can share. Please reach out to me or Will. I'll pause here and I will take up any questions you have.